Okay, we're going to spend 2 days actually talking about the area of shaded regions and irregular figures. So we're going to do the notes today. You'll have a homework assignment. It's short. It's only 5 problems. Okay. And then we're going to do an activity with this tomorrow to practice it some more. And then have another short assignment. Okay. Wednesday will be a review day, and then Thursday the test. Okay. So, what we're looking at, first of all, in the first part of your notes here, is finding the area of the shaded part. Okay. These are not shapes that we necessarily can just have a formula for. So we have to do a process to get there. Okay. On this first one, all I want to find is the area of this gray part. Kind of looks like a moon shape or something. Okay. But we don't have a formula to find the area of a moon. Right? So we need to look at all the shapes we can see here. Do you see different shapes here? Do you see circles? How many circles? 2 of them, right? There are 2 circles in this picture. There's a small circle and a big circle. Okay? And if we take the big circle and we take out the small circle, what we would have left is this gray part. Everybody agree with that? Okay, so let's start by finding the area of the small circle. Okay, this circle right here. I want to find the area of this. How do we find the area of a circle? Really? A equals pi times radius squared. Okay, write that down. What's the radius of that small circle? Here we got to do a little bit of thinking. We need to know the distance from here to here. Zachary? 8. How did you get that?
The other side would be 16, so I just 16, small one.
Yeah. Absolutely, okay? So this whole distance right here would be 16. Everybody agree with that? Because it has to be the same as this other side. And so if this whole thing in the green is 16, that means half of it, the radius is 8. So we're going to do 3.14 times 8 squared and get our answer. Okay, this is where you're using a calculator. 8 squared, 8 times 8 is 64 times 3.14, and I got 200. Hang on, my board's being goofy. Okay, 200. We'll get there eventually. 0.96. Okay. Then we're going to find the area of the big circle. Again, area equals pi times radius squared. What's the radius of the big circle? Brooklyn? 16. So we're going to do 3.14 times 16 squared. And I got 803.84. Okay, the last thing we're going to do is we're going to subtract those 2 circles. I'm going to take the big circle, 803.84 minus 200.96. And at that point, I'm going to round to the nearest 10. At the very end, wait till the very end to round, but at the very end, let's round to the nearest 10. So it's 602.9 is our answer. Okay, that would be just this shaded part. Questions there? Okay, let's look at the next one. Okay, the next one looks like this. What shapes do we see here? You guys agree with her?
Yes.
You see a square? Do you see a circle and a square? Okay, I'm going to make that a little bit more specific. I see a large square, a circle, and a small square. Okay, and part of showing your work this time is going to be just laying it out. Writing down what shapes do you see, because it's helpful to write that down. Okay, so let's start with the large square. How do I find the area of the large square? The big square, what do we do? The area of a square is base times height. So what am I going to do with that? Caleb?
Like 12 times 12.
Yeah, 12 times 12, which is 144. Okay, then let's do the circle. Again, the area of a circle. Area equals pi times radius squared. What's the radius of that circle? Okay, I'm going to draw the radius in. It goes from here to here. What's that distance? Matthew? 6. Yeah, so we know the square is 12. That would go all the way across the circle. So the radius is 6. So 3.14 times 6 squared is 113.04. And then how about the small square? How do we find the small square? Area equals base times height. What's the base and the height of the small square, Caleb? 4 times 4. Okay, now that's great. We have these 3 numbers. What do I do with them? What do we do with those 3 numbers? Caleb, what do you think? Subtract all of them? Okay, so now think about this. What I want is this part. Okay, and then I want the square in the middle. So if I take the large square and I take out the circle, take out the entire circle, that would leave me with just these edges. Everybody agree with that? Okay, so I'd have to do 144 minus 113.04, which is 30.96. Okay, when I did that, I took out everything, right, including the middle square. So that means I have to put back this middle square. How do I put that back? Add it. So I'm going to add 16, and I get 46.96, which rounds to 47. I'm rounding to the nearest 10. It would be 47. Questions there? Okay, let's look at example 3 then. Okay, I want the shaded part only. So let's make up a plan first before we do any math. What shape do we see? I want the area of the shaded part. What shape do we see, Brinley? Okay, she sees a rectangle. Do you see any other shape? Yeah. A triangle. Yeah.
Trapezoid.
There's actually not a trapezoid there. And I was hoping somebody would say that. But you guys, this has 1, 2, 3, 4, 5 sides. So that would have been a pentagon, right? And we don't have a formula for that. However, the rectangle and the triangle, we do. The rectangle is right here. So if I find the area of the rectangle, so I'm going to write this down, rectangle, and I take away or subtract the triangle, we'll have the area of just the shaded part. Everybody agree? Okay, so let's start with the rectangle. Area equals base times height. What's the base and the height of the rectangle? Zachary? 12 times 8, which is 96. Okay, so we started with just the rectangle. Now let's do the triangle. Triangle is area equals base times height divided by 2. Don't forget the divided by 2 part. What's the base and the height of the triangle? Caleb?
6 and 6.
6 and 6. So 6 times 6 divided by 2. 6 times 6 is 36. Divided by 2 is 18. What do we do with these two numbers? Subtract them. 96 minus 18. The area of the shaded part is 78 feet squared. So just this part here is 78. Questions there? Yes.
Are we just trying to find the shaded part?
In the front side, yes, we only wanted to find the shaded part. Okay? Any questions on the front side of our notes? All right, flip the page to the back side. Okay, on the back side, we're going to look at your regular figures. Okay, so not shaded, but weird shapes. Most rooms are weird shapes. Okay, this room is not a perfect square or rectangle. Why not? Kind of looks like it, but why isn't it a perfect square or rectangle? Really? Yeah, the doorway. If you look at the floor has all these weird cutouts because of the cabinets, because of where the door is. Along the wall over there, it has to go around the cabinet and back in the corner. Okay? So it's not a perfect, it kind of looks like a square or rectangle, but it's not perfect. Okay? So we need to be able to find the area of these kind of odd shapes. So if I look at example 4, I'm going to take this and I'm going to break it up into shapes that I know about. Okay? I'm going to divide this one right here. So I want everybody to draw a line right here. Because by doing that, now I've taken that weird looking shape and I've broken it up into 2 shapes that I know about. It's a rectangle and a trapezoid. Everybody agree? Okay. So if I can find the area of the rectangle and I can find the area of the trapezoid, I can just put them together. So let's start with the rectangle. The rectangle is base times height. What's the base and the height of the rectangle? Five times 8. So the area of the rectangle is 40. 5 times 8. And then the trapezoid, now we have to be careful. Remember, trapezoid is base 1 plus base 2 times the height divided by 2. Right? It's that more complicated formula. Do you have to memorize these formulas? No, they're on your formula sheet. Okay. So, what's the 2 bases? Look at that trapezoid. What is the length of both bases, Brinley?
7 and 5.
Yeah, 7 and 5. It's not labeled, but we know it has to be 5 because it's the opposite side of the rectangle. So 7 plus 5 times the height. The height is 4. And then divided by 2. 7 plus 5 is 12. 12 times 4 is 48. Divided by 2 is 24. Okay, and now we just add them together. 40 plus 24, we get a total area of 64 feet squared. Questions there? Okay. Let's look at example 5. What can we split number 5 up? What shapes do you see? What do you see in number 5? And I only see 2 shapes, so we're going to keep it to 2. Really? Okay, a parallelogram, absolutely. And is it a full circle? No, it's a half circle or a semicircle. Agree with that? Okay. How do we find half of something? Can you guys remind me how we find half of something? Really? Divided by 2. So we know how to find a full circle, and then we'll just divide it by 2 to get half. So let's start with the parallelogram. So figure 1 being a parallelogram. This right here. How do I find the area of a parallelogram? Area equals base times height. Okay. What's the base and the height of the parallelogram, Tyler? 16 times 9 is 144. Okay, then the next one is the half circle. So this right here. Okay, area of a full circle is pi times radius squared. What's the radius? Here's the center of the circle. We need to know this distance right here. How far is that? Matthew? 8. Does everybody know why it's 8? Do you see that? Why is it 8?
Because the top number is 16.
Yeah, the top number is 16, and it's a parallelogram, so those have to be the same. So half of it is 8. 3.14 times 8 squared is 200.96. What do I have to do with that number? So remember, that's a full circle. I don't want a full circle. What do I have to do, Brooklyn? We have to divide this by 2 because we only want half of a circle. So we get 100.48. And then finally we add the 2 pieces together. 144 plus 100.48. Rounding to the nearest tenth is 244.5. Okay. All right, one last example. Okay, I want you to try this one. Let's see if you can find the area of that figure. I'm going to give you a couple minutes to work on it. See what you would do. Excuse me. Thank you. Anybody stuck? Yeah?
I almost got it.
Some people almost got it? Okay. So, maybe you didn't get done with it yet. That's okay. How did you start doing this? What did you do? Because there's more than one way to do this problem. Zachary, what'd you do?
I broke it up into some squares.
Okay, how did you do that?
Um,
Can you explain to me? Like, okay, did you go this way?
yeah, I went
So you drew a line here,
and one right
here, and here?
Yep.
Okay, so Zachary did that. Okay, so basically he had to find the area of this, this, and this. Okay, that would work, right? A is, these are all squares or rectangles. So this is 3. What's this? Tyler? 3. It has to be because this whole side is 6. 2 plus 4 is 6. So if this is 2 and this right here is 1, this has to be 3. So it'd be 3 times 3, which is 9. Then we have to find rectangle B, which would be 2 times 3, right? So 2 times 3 is 6. Okay, then we have to find letter C, which is this orange rectangle right here. This gets a little trickier. Kind of. This distance right here is 6. This distance right here is what? 3. Because this is 3. Okay, so letter C, we have 6 times 3 is 18. And then we have the last one. Letter D is this rectangle here, which is 4 by 2. This whole thing is 8. This up here is 6, so it has to be 2. So 4 times 2 is 8. And we add that all together. So 9 plus 6 plus 18 plus 8 is 41. Ooh, that was a long process. Okay? Now, some of you did that, I'm going to erase this. Okay, some of you might have done this different. Some of you might have tried to go like this. Did anybody do that? Some people, okay? Some people might have tried to do this. Okay? All right, all great ways, but can I show you a really easy way to do this? Yeah, right, you knew there was an easier way. There has to be, there always is. Okay, so here's what I would have done, you guys. And some of you will go, oh man, that would have been so much easier. I would have drawn a line right here.
I didn't know we could.
And here. So thinking outside the box a little bit, I would have made this a large rectangle. And then take away this and this. So minus the small rectangle and minus the small square. Some of you might like that way better. Okay, and this would have been 8 times 6 for the large rectangle, which is 48.
Where'd you get 6?
This distance right here would be 6 because it's 2 plus 4. Good question. Okay. The small rectangle, this one right here, 3 times 1 is 3. I'm going to subtract that. And here, this is 2 by 2 is 4. 48 minus 3 minus 4 is 41. We got the same answer either way. It doesn't matter. How many of you like that second way better? Some of you do. Some of you are like, yep, I can see that one better. It doesn't matter. I wanted to show you both ways. Because it doesn't matter which way you do it, you get the same answer. I think the first way, you just have to find more numbers. Right? It takes a little bit more time to find them. Either way works. Okay. So that's